Welcome back to my exhaust fan controller project series. In this video, I'm going to test the prototype to see how well it works, and then I'm going to set it up for operation. This is my final circuit design minus the bypass switch. The cabinet voltage sensor is going to be connected from off-board. I don't have a way to set a specific temperature to be able to test this, so instead I'm going to replace this temperature sensor with a resistor divider. This circuit will allow me to adjust the cabinet voltage with a potentiometer. The output voltage from this circuit is basically just a voltage divider, so I can write this equation immediately. From that equation, I can then set the cabinet voltage to the two values that I would like to have at the extremes, and replace R14, which is my potentiometer, with a specific value. So in the case of 0.7 volts, which represents 70 degrees Fahrenheit, the potentiometer would be 0 ohms. In the case of 1.2 volts, which represents 120 degrees Fahrenheit, the potentiometer is set to 10 kiloohms. I can rearrange both of these equations and solve them pretty easily, but I'm going to show an even easier method. We can just ask Wolfram Alpha to solve this for us. I replaced R13 with X and R15 with Y to make it easier to type this out. When we go to Wolfram Alpha, we just put in that same statement where we have solve the first equation and the second equation for X and Y. This immediately comes back with X is 12,600 and Y is 203,400. Substituting those values into my circuit and simulating it gives me exactly what I expected. At the very bottom of the potentiometer range, I have 0.7 volts at the output, and at the very top of the range, I have 1.2 volts at the output. There's just one problem with this circuit, and that's that I don't have a 203.4K resistor or a 12.6K resistor. So I had to tinker around with these values a little bit to get what I wanted. I first tried replacing these with values from my bin. By swapping to a 200K, which would be two 100Ks in series, and a 10K, I end up with a range of 0.518 to 1.09 volts. That's not quite as high of a voltage as I'd like to see. I'd like to get up to at least 1.2 volts on the positive end for testing. In order to increase the range of voltage at the output, we can't change my 10K potentiometer because I only have one of those, but I can reduce the total resistance across the entire set. I tried reducing to 6.8K and 150K, which are both values I have available directly, and that covers the range I need pretty well. I set my bench supply to 12 volts for this. I would have used the same power supply that I was planning on connecting to the final design, but it's already powering the fan in my desk, and I didn't want to disable the fan while I was working on the replacement circuit. Instead of hooking up an actual fan for my test, I connected an LED to the output, which will let us have a visual indicator of when the fan is on or off. I hooked up some jumper wires to connect my breadboard where I'll build my simulated LM34 sensor. It didn't take me long to throw together the voltage divider circuit. Before starting my tests, I just quickly verified that the output turned on and off as expected by changing the potentiometer value. With that confirmed, I moved the circuit off screen and brought in my voltmeter so I could see the input voltage as I changed it. The bottom value is about 520 millivolts, just like I'd expect, and it's easy to adjust. Before starting my tests, I'm going to check the room temperature value. Looks like it's 76.3 degrees in here. For my first test, I set both potentiometers to 0 ohms and checked the trip points. In this condition, we expect to see no hysteresis, meaning the on and off temperatures should be pretty much the same, and the output should start changing right when we exceed the room temperature. You can see that the LED just flickers on at 0.766 volts and off again at about 0.765. Without any hysteresis, the output is slowly ramping instead of turning on all the way immediately, so that's why we're seeing the LED just barely turning on instead of flipping all the way on. For my second test, I set the offset potentiometer to maximum and left the circuit without any hysteresis. In this state, we expect to see the trip temperature increase, but there still shouldn't be any hysteresis. We expect that the LED won't turn on very brightly for the same reason it didn't the first time. This third test is where we add in the hysteresis. Now both potentiometers are at maximum, 10 kiloohms. This would be the highest temperature rating I could use. Since we've added in the hysteresis now, we expect the comparator circuit to do its job and immediately make the LED very bright when it trips. It turns on right around 106 degrees and turns back off again around 87 degrees, giving me a total of 19 degrees of hysteresis maximum. For my fourth and final test, the hysteresis is set to maximum and the offset is set to 0. We see that the device triggers as expected with the turn-on point at 96.2 degrees and the off point at 78.5. The room temperature did increase a bit while I was working on the testing, going up to 77.6 degrees at the end, but the 1 degree of change shouldn't make much of a difference for my tests. In my simulation, I was seeing a maximum of about 24 degrees of hysteresis, but in my final design, I'm only getting about 18 or 19 degrees. This is probably due to tolerances in my components. It's not a big enough variation for me to worry about looking into the exact cause, especially since I'm only planning to set about 10 degrees, so I think this circuit meets all of my expectations and I'm ready to set it up for use. My first step to get it set up is to set the trip point without any hysteresis. This makes it easy for me to adjust quickly. I want to add a little bit of an offset so I'm sure the fan will turn off properly, so I'm going to set 2 degrees as my initial offset. I'm doing this by setting the input temperature to the desired trip point, then adjusting the potentiometer on the board until I see the LED turn off. I then turned the potentiometer just a tiny bit more and tested the circuit. It looks like the trip point is at about 80.5 degrees, which is close enough to what I wanted. Next, I added in the hysteresis. I wanted to get about 10 degrees of difference between the on and off voltages. To start, I set the value to maximum to see how much I could possibly get with this configuration. It turns out that I can get up to 21 degrees with this setup. I adjusted the potentiometer down to about half and tested the operation. The final setup has a turn on at 92 degrees and turn off at 82 degrees, which should work great. Remember that this is directly related to the room temperature, so it's actually turning off at the room temperature plus 4 degrees and turning on at the room temperature plus 14 degrees. Thanks for watching. In my next video, I'm planning to create a more professional style board for this using Circuit Maker.